Executive Director and Head of Institute at EPCC, which is the High Performance Computing and Data Center at the University of Edinburgh. She has been with the Center for over 20 years, and the Center is responsible for national and local high-performance computing services, mainly for the academic research community in the UK, but also undertakes industry technology transfer projects. And is very active in the large European research and infrastructure projects, including CRESTA, which is the Collaborative Research into Exascale Systemware Tools and Applications. She's a board member for the Partnership for Advanced Computing in Europe, and is on the executive board for the European Data Infrastructure, as well as the steering group of the UK Numerical Algorithms and Intelligence Software Center. Very, very busy person.
I am.
And so she started as a project and program manager. She has her background is quite varied, with degrees in politics and sociology from the University of Edinburgh, mathematics and technology from the Open University, and a business administration degree from Heriot-Watt. So please join me in welcoming our guests.
Well, thank you very much for inviting me to Canada. It's great to be here. As you can probably tell, I'm from Scotland, from my accent. So at EPCC, we're mainly working at the interface now between HPC and data. So what I'm going to talk about is some of the work we're doing at the University of Edinburgh, where I think we're mirroring what's being done here in terms of pulling people together into an infrastructure. Some of the work that we're doing in a European context with the European Collaborative Data Infrastructure. It's going to touch on, I think, policy and sustainability, which are some of the issues that we're having to face there. And hopefully we'll have some time for questions at the end and discussion. So first of all, I thought I'd start with the definition, what we're taking as our definition of big data. So the big conference in our area is supercomputing. So it's a really large conference held every year in the States, about 12,000 people. So I've been working in data infrastructures for 2 or 3 years now. So it wasn't a huge surprise to me that suddenly big data has taken over HPC and everything at the conference is about big data. But a number of my colleagues were quite upset by this. So we started this discussion on what the definition was. And the best definition that one of my colleagues could come up with was something that somebody had said at the conference, which is big data is like teenage sex. Everyone talks about it. Nobody really knows how to do it. Everyone thinks everyone else is doing it, so everybody claims that they are doing it. So I think starting from that point, we felt a lot better. You know, if we share our experiences with other people, then hopefully we can all come to a better way of doing things. So a little bit about EPCC. So it really stands for Edinburgh Parallel Computing Centre, but of course that's a very dated term because no one talks about parallel computing anymore. So, so we were founded as a supercomputing centre for the University of Edinburgh, which is a classical university with a strong research focus. In university terms, we are quite young. The university was founded in 1584, I think, and we've been going for 24 years, so we're one of the youngest departments. We've got about 75 staff, so about 55 of them are programmers. And the rest of the technical staff, we've got a number of systems administrators, systems developers, some business development people. But we are very technically focused. We bring in people from all sorts of different backgrounds. So the requirements are you have to be a good programmer and you have to be outgoing. You have to be prepared to go out, talk about your work, make links between different areas, and of course you have to bring in business. Because one of the things that we've got is we're multi-funded, but very little of our funding comes from the university. We get a small amount for teaching, but the rest comes from collaborative research and projects. So everybody has to go out, make links in the UK and in Europe and bring in work. And when you bring in work, you can then direct your own research career. So that's the way it goes. We're based at the Science Campus in King's Building, so it's a campus very like this one. We're all crammed into a number of offices, small offices, whereas our computers have a fantastic new building. So I guess that's maybe the way it is. So we have a new machine room which costs £12 million and offices which are never renovated. So all the money goes into power and cooling. We're part of the University of Edinburgh, as I said. So this is one of the older parts. This is the central campus. You can just see the informatics building in the background. So that's fairly new. The university, I think, is very similar to Western in that we've got about the same number of students. I think we have 32,000. The university likes to claim it's a top 20 world university, and I think we prepped under one measure in 19th, but typically we're probably somewhere around the top 50 in the university, depending on how in the world, depending on how you measure university's performance. So we have about more than a third of our students are Scottish, but we have a lot from the rest of the UK, from the European Union, and we have a strong international presence, which is important for continuing our research collaborations, bringing in new people with new ideas. So I don't know what the balance is here, but we're over 60% humanities and social science. We've got a strong medicine and vet medicine facility, and about 24% in science and engineering. So although we in EPCC like to think that high performance computing is very important, it's only very important to a small segment of the science community, whereas big data the university is very interested in because that's going to involve everybody, all three colleges. So why is the university particularly interested in it? Well, the first thing is they see that big data is going to have a huge contribution to research excellence. The system we have in the UK is all the researchers, all academics will get graded on their four best papers. There's also points that you get for the impact of your research, which involves how industrially relevant it is, what society benefit there is. So obviously, with large data sets, the people who are in a position to analyze these data sets and publish first are going to get the best papers and the ones with the highest number of citations. So that's an important motivation for it. There's also the potential to host a number of data centers which will have open data or large data sets, which again will facilitate collaborative working. We see that big data is opening up new areas of cross-disciplinary research. So at the moment, the university is creating 50 new posts, and the idea is we'll bring in people who have interest in big data research, and they'll be there to work with centres like EPCC. So that's specifically new people, ideally interdisciplinary. We know that there's a big demand out there for data skills. We get told by the government all the time that we have to increase the number of graduates with STEM skills, so that's science, technology, engineering, and maths. So pressure to produce the kind of graduates that industry wants. And we know that we can't do that by the traditional means because we have to train people across all the disciplines. You can't do it by bringing in the odd PhD student and having them learn from their supervisor because, frankly, probably the PhD students know more about big data than the supervisors. We also see that big data is of increasing importance to industry and academia, so there's new potential there for a lot of interesting collaborations. So what we see is that the big data is changing the infrastructure landscape, and it's offering some really good opportunities for universities. So a little bit about the background in the UK. We're in a very competitive environment. From the 80s, we have this legacy of Thatcherism where all contracts were put out to tender, that universities have to bid to host any kind of services or infrastructure. We have science policy that's managed by a number of different research councils, and for infrastructure projects, sometimes they'll buy equipment and services separately, sometimes they'll put their money together and collaborate. So obviously we have to try and convince them of where we think it's a good idea to collaborate to get something that's suitable for a number of different research areas. We have the occasional large-scale initiatives. The most famous one recently was the eScience programme, which ran in the UK for about 9 years. There was a lot of money went into that, but it was so successful that the government said, "You've told us you're so successful, we presume now that you're sustainable, so we're going to cut off your funding." So I think what people are trying to look at in big data is, will something similar happen in big data? And if we are then putting things in place now, how can we make it sustainable? Okay, so a little bit about our funding model. As I said, we're self-financing. So we have several strands to the work we do. Firstly, the vast majority of our staff are paid for from research grants and from service provision from running the national services. So basically that allows us to learn some new skills through new projects and to cover the salary costs for most people. We also, as part of our contract to run the national services, take a reduction in the money that we're paid, and we partly get paid in kind. So we then have control over 5% of the national HPC resources and 5% of the data infrastructure. So these are owned by the university, or they're not owned by the university. The university is allowed to use them for any university projects or any work with industry. So that also allows us to go out and do work with industry to allow them to use the national facilities, and we can charge for that. We can charge for the CPU cycles, and we can charge for working with them. So this again gives us a bit more flexibility and will allow us to do work in HPC and big data that perhaps we wouldn't be able to do otherwise. Because we're part of a university, we don't make profits. We have surpluses, so we go out and we spend the surpluses in new equipment. So I think when we're thinking about infrastructures, it's quite easy in an HPC way to differentiate whether you're a large facility or a small facility. We have this notion in Europe of tier 0, tier 1, and tier 2, where the very biggest facilities are tier 0 and the regional and university ones are tier 2. So with HPC, it's quite straightforward. If you spend a lot of money, you buy a very big computer. It's got a very high LINPACK rating, which determines where you are in the world. So it's a bit like cars with a, 0 to 0 in 5.3 seconds, and you get a ranking on that. But it's much more difficult, I think, with data centers. So if you're in an ambitious university that wants to have themselves up there as one of the big ones in big data, what sorts of services do you put in place, and how do you do it? So the way that HPC is going to big data is really this way, through this fourth paradigm. So basically, when I started in HPC, there was the idea that there was theory and experiment, which were the traditional scientific methods, but through computer simulation, there was this new way of looking at problems which were too big or too complex, or over too long a time scale to do through theory or experiment, so you would simulate them with computers. So in 2009, a very influential book was published by some people in Microsoft, which had this idea of data-intensive science discovery. So the view that came out there was that there was a lot of important science that could be done by mining existing data, using new computing and data analytics techniques. So obviously we are continuing to accumulate large amounts of additional data, but we should also look to the data that we've already got. So one of the points made in one of the blogs, which was talking about this, was especially in earth sciences, there's a lot of data that was collected not for academic research. For example, archives of seafloor surveys that were put together for military reasons for submarine warfare are out there, and researchers can use them, plus a lot of data that's collected for mineral and energy exploitation. Other examples that I've heard of is apparently in Sri Lanka, they managed to convince Orange to open up some of their mobile phone data so they could analyze that quickly, and it showed, unsurprisingly, that a lot of people migrated from the countryside to the towns to work during the day. Now that may not seem like a big research problem, but it was something that was really easy to find from existing data, whereas in a country like Sri Lanka, it would be difficult to do that kind of a survey and collect the information from the population. So obviously, putting the right policies in place and convincing companies to open up their data so it can be used for social research or other research is an important part of policy. So that's one of the things we think that we have to try and work at. So various people today have already talked about characterizing big data. So from our point of view, the area that we're mainly looking at is high-performance data analytics. So that's the area between high-performance data where people need fast computers to do some of the data analytics, complicated algorithms. So that's where we're hoping to move into. So obviously with commercial analytics, a lot of these companies are moving to HPC. the HPC companies, vendors obviously see that there's huge commercial opportunities in big data. So there's a lot of opportunity for universities to collaborate there. So why do HPC centres have some sort of an advantage? Well, we've already been doing big data with small d, for a number of years. Basically, any kind of a problem that we're doing with industry, they typically don't differentiate between data and HPC, so they'll come in with their problems. We've been processing large volumes of data from instruments for years. So the requirements of big data, as we see it, are very similar, but the types of people who are coming with problems or issues are different, and the areas are much more numerous. So I think that's one of the reasons why we have to bring in lots of new disciplines, lots of new people. And particularly, I think there's a lot of solutions out there from humanities, social science, where people are developing their own tools which have much wider applicability. So rather than thinking, oh, we have all the answers, we have to work with people who've developed their own solutions and try and see how they're applicable in a wider world. And also, I think we don't, in the HPC centres, we know that we don't really have the answers to a lot of problems to do with dynamic data, where we have to do real-time processing. Unstructured data, we don't have as much experience with that, and databases where you may be having to deal with lots of different layers of data. So again, we need these partnerships to make things happen. So one of the questions that we're trying to struggle with is what is a data infrastructure? Are we really looking at storage? Are we looking at a range of services that you need to provide as a university? Or is the data itself the infrastructure? So to some extent, there are some parallels with HPC, where the idea of software as an infrastructure is becoming more important, particularly in Europe, where we think we're very strong in software development, because we can't really compete with the States in terms of, or Japan or China in terms of going out to buy really large machines. So we specialize, I think, in software development. Okay, so one of the other things that we've discovered is that there is this hierarchy of data needs. When you're putting in any kind of a research proposal, you get your money from talking about the value of sharing data and combining data. Because that's the sort of thing that everybody wants to do. They want to share data across communities. They want to be able to combine data to come out with new insights. However, what we've discovered is that people will not talk to you about sharing data unless the rest of the infrastructure is there. So what you have to have in place is a sound method for storing and archiving data. You have to have security. You have to have standards for metadata. You have to improve reusability and usability. And unless you have all these layers in place, it's all very well to talk about sharing data, but we as universities have to help people to provide all these other layers so that we can then go on and do the exciting, sexy part. Okay, so what are we doing in Edinburgh? And by the way, I think it's similar to what you're doing here. So we've decided on the term Edinburgh Data Science. We decided we didn't want to use the term big data because that would probably date. So we're putting together an umbrella organisation which is going to facilitate cross-disciplinary research and teaching. So coincidentally, we've had 3 research centres which have recently come into the university. But now they're not entirely Edinburgh University. Most of them are collaborations with other institutions. So there's one in medicine called the FAR Institute, which is distributed across the UK. And for example, one of the challenges we have there is we're getting delivery of a very large number of, I think it's MRI scans, which have patient names and patient NHS numbers directly embedded into the JPEGs. So somebody has to go through and remove all that information to anonymize it before that can be used. We have something called the Digital Health Institute, which is a collaboration between art schools, informatics people, EPCC, and some health companies with a view to designing products which are going to help an aging population. So the sort of thing they're looking at doing is embedding devices into jewellery to make them more attractive to older ladies who perhaps don't want to wear these large red buttons that they hit if they fall. So that's an interesting project. And we also have an admin data centre, which I know less about, but that's local government data and is going to impact on smart cities. So what we felt is that we have a number of underpinning activities in Edinburgh. We've got HPC and data storage facilities at EPCC. We have something called the Digital Curation Centre, who are experts in data management planning. We have very strong mathematics and informatics departments who are doing a lot of theoretical research. And we have HPC and data expertise at EPCC, where we largely do what I think is now called translational. We provide translational services, which basically means we take the theoretical work and we apply it in industry or in other areas. So the view is that if we put together this umbrella organisation, we should be able to position the university better to respond to additional calls for national data centres. We're going to be able to respond effectively to demands for graduates and postgraduates with the right sorts of data science skills. And we'll have a way in for companies, for the commercial sector, to interact with the university. At the moment, people can come in through a number of different areas, and it's not very clear which departments they should be working with and whether or not we can deal with them as a whole. And of course, we hope then to get some joint activities with them. So data science skills are the main barrier that we think we've identified to expanding faster, our activities faster. And there's this McKinsey report which forecasts that in the States alone there's going to be up to 190,000 shortfall in data scientists by 2020. So what we've done in Edinburgh is we've made a list of the sorts of skills that we think we'll need and that probably we already have in the university. So I guess it's the same sorts of things that you're looking at. Statistics and statistical modelling skills, mathematical skills, including operational research and algorithms research, data engineering, including workflows, machine learning expertise, software and middleware development, visualization skills, and the ability to deal with spatial data. So the idea is if we can bring together expertise in all these areas, then we should have a core with which to go out and speak to other people. So, as I said, we see that really that education and training is where we should be starting in the university. So, for example, we already run a master's course in high performance computing. A lot of our master's students go out to do projects with industry. And one of the things that we noticed over the past couple of years is that these industry people are increasingly asking for skills that our students don't have. So basically, the supervisors then have to train them up in data, some of the data skills before they do the project. So we thought, well, it would be better if we actually wrote some courses. So we're doing, the two that we're doing immediately is a fairly boring one on the fundamentals of data science. So that's the dull stuff that you need to know. And the one that's going to be a bit more exciting, data analytics with high performance computing. So we're going to put them into an MSc from this September. So we do a couple of these courses and a data project, and we'll see how that goes. And other areas of the university are looking to develop some other courses for the next year, which we'll also contribute to. In the meantime, we're trying to have a sort of a training cooperative. We're going to build up some courses for PhD students and staff, taking all the expertise in the university and perhaps having a data training week or a couple of data training weeks where people can come in and listen to lectures or talks from some of their colleagues in other departments. So we think then we need this portfolio of material that can be configured in different ways. So perhaps we'll have some common material. So the intention is we'll try and have some common material, and we'll perhaps have different data sets or different practical training sessions using different packages to train different people. We're looking to have partnerships with industry and vendors so that they can provide additional training because they also have these needs for students. A lot of them are quite keen to come and contribute to our training with a view that we'll help to teach the graduates of tomorrow the sorts of skills they'll need. So they'll provide part of it. Other companies will provide other things. Together, we'll come out with this body of people who are fit for industry. And of course, we're also going to be looking at distance learning possibilities because that's where some of the money and some of the market is. So I'm going to say a little bit about what's happening in Europe and the changing situation there. So we have this thing that's been established over the past 10 years, which is the European Research Area. And it's encouraging very active collaborations between HPC and data centers. So we have two things. We have PRACE, which is similar to EXCEED in the USA. So that's the collaboration of all the large HPC centers. We have UDOT, which is a collaborative data infrastructure, which I think is similar to Data One in the USA. I apologize for not knowing exactly what you have in Canada. So at the moment, we have this hierarchy or mesh of data infrastructures with a number of them serving particular communities. And what the Commission is encouraging us to do is to try and develop some common data services between these infrastructures. So we have this overall European collaborative data infrastructure, which is aimed at cross-European communities and initiatives. So it came out of a high-level expert group which produced a report called Riding the Wave. And the view here is that for most research groups, they are both generators of data and users of data. So that each research community has some services which they'll develop themselves for their own use, but they can also make use of some common data services. If we can identify what services are needed across all communities, we can produce them in a more cost-effective way. Plus, there's issues like trust and data curation, which they see as cutting across all the communities and involving people outside the data area as well. So that's what the area we're working on. So the EUDAT project's been running for about 2.5 years. There's 25 partners, a mix of user communities and data centers. Initially, we've identified 7 communities to work with, but the number is now up to 40. But these are the ones who are actually members of the project. So what we did was we chose fairly structured communities who already had some degree of data infrastructure, but who had different requirements and different expertise. So for example, the Claren project, which is digital language, they're very strong in metadata. And they understand the importance of keeping lots of different copies of things, so they can bring some experience there. The earth sciences people are doing a lot of work with sensors, so they're experienced in dynamic data. The LifeWatch people are going out and collecting data from a lot of researchers. So they have citizen science and lots of different people reporting in. So again, they have a different expertise. VPH is the virtual physiological human, so they understand some of the issues of privacy in data. INCF are already users of HPC. So you'll see that the various communities have different expertise, and they're bringing it all together to allow us to try and build something to share data between communities. So the 3 things we're looking for is putting together something which is easy to use, driven by user needs, and is going to be sustainable beyond the lifetime of the project. So the way we're trying to do that is via a partnership model, which will allow various people to contribute to the project and to use the services, so that we can incorporate any services developed by other projects or other infrastructures, bring them in, and have some consensus about how this shared services model can be extended to meet continuing needs on an ongoing basis. And it's also very important that we're going to be able to incorporate new data providers and new data users. So this is just a bit of a warning, nothing to do with our project, but it's a case that's been that's caused a lot of controversy in Europe. That some researchers and public officials were jailed in 2012 because a lot of money in Italy had gone into research in earthquakes, and they failed to predict the severity of an earthquake. So they were judged to have failed because they hadn't managed to predict this earthquake. They'd given, I think, falsely reassuring, I think that's the phrase, they'd given falsely reassuring information that it wasn't going to be that bad. So that's obviously one of the things that people are aware of, that with a lot of money going into data infrastructures, there may be unrealistic expectations about how quickly we can deliver new services and come up with the right answers. So what do we think? We obviously know that sustainability of a data infrastructure is going to depend on economies of scale, leverage between different projects, and widespread uptake. So we're trying to look in three directions. So horizontal integration, where we'll add new communities and service providers. Vertical integration, where we'll broaden the range of services offered. And if you like, the third dimension, where we'll collaborate with other infrastructures so we don't duplicate effort. So we're also developing something called the Community Integration Toolkit, which will look at some of the issues in engaging new communities and service providers, the policy, process, legal, ethical, and technical issues, so that people know exactly what they're coming into when they join the infrastructure. So what we're trying to do with the initial services, we're trying to develop them fairly quickly using existing technology, but have well-defined interfaces which will allow us to replace some of the technology if newer things come along. And obviously we want everything to be open source so that we can be flexible. So for example, one of the services that we're developing now will allow data to be staged between the data infrastructures and the HPC infrastructures, so that it can make use of the HPC facilities, but also that we can take the data that's been generated and put it back into the research infrastructure so it can be preserved in the long term. So one of the issues we have at the moment is that people use computers all over Europe, and then when their access period is up, somebody says, right, you've got to take your data off because the next lot of people are coming on, and there's often nowhere to put it. So the idea is we can have something that's a bit more integrated. That will help. So the services that we were initially looking to develop, persistent identifiers and authentication and authorization are ones that are being done not just by the project, but in conjunction with some of the other infrastructures, because they're obviously quite wide. We're looking at having something called B2Find, which is a metadata catalog of everything that's going to be in the UDOT infrastructure. We have a safe service, which is looking at data curation and optimization of access. As I say, the staging service, which is going to move data to compute, and something called B2Share, which is a simple store. So the idea is that for long-tail data, we have a service whereby researchers can upload their data and share it with others. And we'll collect some simple form of metadata on that. So some of the questions, the broader questions that we're looking at is, how are we going to sustain these data infrastructures where we've got short-term project funding but long-term commitments? So a lot of the time, if you're bringing in somebody's data, they're expecting you to keep it for at least 10 years. So how do you do that with a project? So as I say, it's the sustainability, not just of the physical infrastructure, but of the data services. The other question is, how are we going to support international collaborations when most of our funding and infrastructure is national? Are we allowed to take other people's data and use it there? How much do we actually need science-driven data infrastructures? What sorts of things could be done better or cheaper by commercial service providers? If we're trying to cost how much it's going to be to take data in, do we actually understand how these costs are going to scale? You know, if you're giving somebody an upfront cost now and you're saying, we'll keep your data for 10 years, you have to be pretty sure that you understand whether you're going to be burdening yourselves with something that's completely unrealistic. So these are all questions for which we don't have answers. However, we've come up with a number of principles that we're going to try and follow in the European data infrastructure. So first one, data deposited, we'll keep it in perpetuity. And the view there is that if hardware continues to get to be cheaper, then that won't really be a problem. Even if the project isn't sustained forever, then the individual data centers who are part of the infrastructure will be. Access to data is going to be free at the point of use. So obviously somebody's probably going to have to pay to deposit it, but it probably comes out of project funds. We're not going to charge any users. That it's going to operate as a federation of the repositories and hosting providers, so that it's easy for people to join and leave without the infrastructure breaking. Wherever possible, we're going to use existing standards. So the one that we've identified is the Trustworthy Digital Repository Standards, so we don't have to invent that ourselves. And the UDOT is not going to assert ownership of any data that it holds, that the ownership of the data will reside with whoever it is that's deposited the data. So one of the things we're looking at is where exactly do the costs lie? So the only information we've got at the moment is really from these digital repositories, where the view is that it's staff costs that are important, and that it's the acquisition and the ingest of data that takes all the staff time. So the view there is if you have the right metadata when you put your data in, it's going to be usable, and it's worth putting a bit of effort into that. But that's a question of who actually pays for that. So we've been talking to some people in the Netherlands, for example, for the digital repositories there, you get something like a couple of hours free when you deposit your data with a data expert who will sit down and help you with your data, and anything beyond that you have to pay for. So is that the sort of thing that we should be doing? But we feel that this is probably an area where academic providers can differentiate themselves from commercial providers. If we can provide the sorts of services that help people to write their metadata, store their data so that it's going to be accessible and reusable, that's an area where I think the Amazons of this world are not particularly strong, where it's really, we'll keep your data, we'll try not to lose it, but if we do lose it, sorry. Okay, a little bit about what we're doing in Edinburgh. In association with the Archer National Supercomputer, the research councils have bought us this research data facility. So it's a nice big facility. Currently, it's being upgraded as we speak. I think it's currently about 15 petabytes of long-term storage, and it's for UK research data. So the idea is it can be for anyone. However, one of the things that we're trying to get over to the Research Council, while we're very grateful that they bought us this facility, the initial view was that really it was just a big file store that was associated with the computer, and it would be nice and easy for anybody to deposit their data in there and find it again. So we've had to go, a bit more difficult than that. So we're working with them to establish what we need to do as a minimum in terms of how do we provide replication. You know, it's obviously different from disaster recovery, so we're having to explain that. What we're going to do about persistent identifiers, is that something that we can impose with UK data? What sort of basic metadata are we going to get people to put in with it? And we also have to think about how data is stored and organized so we can have efficient movement of data to compute or compute to data. So one of the ways we're trying to do this is we're trying to look at two of the areas in the university who are the biggest users of data. So the two we're looking at are galaxy search and animal genomics. And apologies to anybody who actually knows anything about these areas, because I don't know very much. So I'm probably going to summarize it, but summarize it in a very general way. So basically, with the astronomy data, there's data coming in very fast. They only have the capacity to keep the data, keep 15 minutes worth of data that's coming in from telescopes at the moment. So what they're looking to do is use computer simulation to try and model the sorts of events that they're looking for in data. And then you then compare these simulations with the data as it comes in, and if you see something that looks like whatever it is you're looking for, you can store that data. So obviously that needs to be very fast. You need large amounts of storage linked to compute so that you can do that analysis, and links to other centers so you can store the data. So we've started that one. The second one that we're doing is with the Roslin Institute, so that's animal genomics, looking at some of the storage and analysis challenges of DNA sequencing. So obviously that's an area where requirements are growing very fast, and we need to understand what they need. And in the pilots, the view was that the pilots would really just have to look at technical issues, but again, of course, we're going to have to look at policy issues. Okay, I'll speed up a little bit. So to say a little bit about some of the data sharing dilemmas that we've come up against in the UK. You may have heard of ClimateGate, where large amounts of data were stolen from servers at the Climate Research Centre. a few weeks before a major climate change summit by groups who were very opposed to, who thought that global warming was a scientific conspiracy and that it was all a fraud by the government to increase taxes. So I think there was impact from this on open data in the UK. While they didn't find any evidence of fraud or scientific misconduct, they encouraged scientists to avoid similar allegations in future by opening up some of the access to supporting data and with the research and to talk about to show how they'd processed it and to honour freedom of information requests. So two of the things that were highlighted was it was important to provide access to your scientific data to outside groups so that they could independently check your research, even if the people who asked for your information had radically differing beliefs from yours. You still had to open it up. And also limitations of peer review, that there was a suspicion that the system could be used, not that it had been in this case, but that it could be used to stop any critical papers being published. So again, the drive is when you publish, you have to provide access to the data that you use for your papers and also to any software that you used for it. One of the second sort of dilemmas we're looking at is for some example, for some environmental scientists who are uploading information about where to find species who are at risk of from poachers, is how do you stop that information that you've uploaded being used by the very people you're trying to protect your animals against? So if people are out working in the field, it doesn't just apply with conservation, obviously, but if people are out working in the field and they're uploading data, what sort of policies do you put in place? You can't really have user agreements or privacy policies or legal policies, although it may be quite clear that some projects don't intend their data to be used in certain ways. But how do you enforce that? And how do these data owners approve or limit access to their data? Again, something else we don't know how to do. Briefly, I was going to examples from the UK of open data and healthcare. I think this maybe relates to one of the points that we were discussing earlier on with prescriptions. That we have this Open Data Institute in the UK, and its view, what it's trying to do is foster the exploitation of open data. So it's a not-for-profit company set up by the government. It has a number of startup data mining companies, which are doctors and programmers, which are co-located with it. So one of the projects that they did was they looked at prescriptions written by family doctors in England, which are part of the open data, obviously anonymized, and they were trying to look at regional differences in the prescription of statins. Statins, huge variety in costs. So branded drugs can cost up to 20 times more than the generic drugs. So what they were looking to do is see whether it varied by region. And they found that there was a big discrepancy. So the view there is that this research is not done for the sake of trying to get doctors to save money, but that if you can provide information about what other people are doing, you can see how close you are to the norm. And that may be the best way of, in time, trying to save money so it can be used for other things. So that's one example of what's been done with open data. A second interesting one in reuse of data relates to ancient Irish texts show volcanic link to cold weather. So what researchers did was they compared some data, ice core data, indicating volcanic eruptions, with some of the entries in the Irish annals. So they were able to associate these volcanic events with some cold weather extremes recorded in the chronicles. So that's obviously an interesting example because it's data that's being used that was recorded for a completely different purpose that's being used many years later, many years later, for a purpose which its original authors could never have foreseen. But of course that depends on researchers making these links. Okay, so to finish off, what have we found out in EPCC and what do we think the infrastructure providers should be trying to do or mandate? So some of these are fairly obvious. We have to try and make data accessible and discoverable. So we must enable, when we take in data sets, we have to make sure that they can be easily found and easily used. So this includes promoting the use of widely used formats wherever we can do that. We have to try and insist that when we accept data, it's at some minimum level of reusability. It has to have some sort of metadata which describes what it is and how it can be used. Ideally, we'd like some examples of how it can be done, and ideally it should be queryable using a well-defined application programming interface like SQL or whatever. Infrastructures have to provide good tooling to allow researchers to deposit and curate data, and also to help with its reuse and refinement. How can infrastructure providers facilitate interdisciplinary use? Well, the simple answer is you can't, because we don't know ahead of time exactly how data is going to be reused. But so we've decided that we have to focus on what we can do. So again, some fairly obvious things. Encourage the data to be made available under an open license. Encourage or mandate the use of common and open data formats so people can reuse it. Insist on the data being described in a way that references common schemes. For example, say using Ordnance Survey coordinates rather than some makey-uppy non-standard schemes. We should also try and mandate the use of digital object identifiers, which will offer a unique pointer to a data set, because that's important for tracking use and citations. So that means that it encourages data to be deposited, because researchers can get credit when their data is reused, and they can see when it's reused, and we can see also how long we have to keep data for, because we can see what data is valuable to other people in the community. So thank you very much.
Questions, comments? From there, from there.
Thank you so much for this very interesting presentation. I was interested in your program that you're building, the master's program, and
yes.
You did discuss the types of skills that you need, which are across disciplines. What kind of people are coming to your master's program? Do you have people that are coming from other areas than computing science? How do you merge their backgrounds in joining them in these classes? Is that a challenge?
At the moment, the master's program that we run in EPCC is really only suitable for people who already have a programming background. So it's a one-year master, so it's kind of a limitation of the two-semester model that we've got. But it is something that we're looking at. So one of the ideas is that perhaps if the program gets a bit bigger, we can introduce, we already have a course which is designed for biologists and engineers, but that's if you like, it's a short, fat course. And what we do there is we use things like MATLAB and R that people are already using, and we introduce them to parallel MATLAB, so they can get some idea of how HPC might help them with their problems. So we probably have that side of things and change things, but I think we have to do that in conjunction with biologists, engineers, chemists, whatever. So it's only a start, and that there's a long way to go. But the intention is that we'll develop some of the material we've got in the university into a range of data analytics. So it'll be, biology with data analytics, chemistry with data analytics, or whatever. We have a plan.
Just wondering about the elephant case. Why isn't encryption able to solve something like that, like encryption, access control to data?
I think it's this is not something I know lots about, but I think it's that the information can come in from a variety of sources. I think it can be everything from I am a tourist, or I am a traveler and I've taken pictures and I know that there's elephants in this area, or it's not just elephants, it's rare flowers or all sorts of things. So it's not always done by people who are using particular tools that can enable encryption. And there's obviously a dilemma there. Do you make it difficult for people to upload the data so it can be protected, or do you want to keep it open so you can collect as much data as possible?
Yeah, some universities are considering considering or implementing mixed sort of commercial and proprietorial data centers. So I think Stanford is using Amazon as well as its own facilities. Have you considered that route? Did you consider that route? Or
we are considering that route because obviously, as I said, there are things that we know that we can't compete with on price. So it would be stupid for us to try and do something that somebody else can do better or cheaper. So there are some researchers in our university that are using commercial services, but we really, I think, have to understand some of the requirements a bit better. There's also issues of, should we be storing commercial data as well, so that they can use HPC? So that's the other side of things. For example, I think we're talking to a company at the moment who suggested that they might like to store some of the data at our facility, but they'd want the perimeter of the building to be protected by guard dogs in case someone came in to steal their data. So there's obviously, so there's obviously there's a lot of different discussions going on. So there, there are people for whom Amazon is definitely not suitable, for whom perhaps even universities are not suitable.
The idea of bringing together lots of different groups is it's multidisciplinary, interdisciplinary context. You're also dealing, particularly in the European context, with the international context. How have you found national traditions of science or of models of supporting science or whatever? How is that either worked well or worked against coming up with sort of common cause on the EU front?
If I'm going to answer that honestly, sometimes coming from the UK is quite difficult, because you'll know that the UK is very, we are an island, there's the UK and Europe, so that most things can be done better in the UK, and we have different priorities. But I think it's only through doing international projects that you can begin to break down some of these barriers, and you can convince your researchers or your councils that there's a lot of things that they can learn from other countries. The other side of it is obviously there are different priorities. As you suggested, there are different priorities in different countries. For example, one of the things we've learned is that, unsurprisingly, the Netherlands are very keen on sort of monitoring water levels, whereas in Scotland we live in a nice high country, so we don't really care that much about global warming and sea levels, raised sea levels. So that's not a big priority for us. But it's good for researchers in the UK who are working in that area to be able to collaborate with people in the Netherlands who have good funding for that, and vice versa. So some areas are much more advanced in terms of the collaboration than others. But I think it's a question of trying to help the ones who are not as far advanced, because the communities are not as structured, by putting in place whatever we can to help them by understanding their requirements a bit better.
Any other comments, questions? No? Well then, thank you
Thank
very
you.
much. Okay, with this we come to the end of our first day of Big Data. As you know, tomorrow we'll continue with the SHERC regional event related to imagining Canada's future at the Great Hall at 8:45. You are all welcome to participate, no matter what disciplines you work on. Just a final word about a couple of things. One is thank you all of you for coming out today, and thank you to the presenters, the speakers, the panelists, and people from all the faculties really helping to put this together. The second question is a little concern that we have in the working group putting together the paperwork for the big data potential research cluster, and has to do with the fact that most of the issues that we deal with is that it's a truly multidisciplinary effort, and we have to go through a lot of barriers of language, politics, different approaches, etc. So we want really to know from you if this is really worth the effort, if you really think that we in all faculties and departments need this kind of initiative, and if we can really bring it together. So please email us, either Mike, Andrew, Jackie, Hanan, Sergey in engineering, or myself, to really give your opinion about how things should be, how you think that we should try to run this first really multidisciplinary initiative across Western. Okay? Thank you again, and have a good night.